Yo, what's up, YouTube? It's Crackatombine. And yes, continuation of the physics assignment. Let's go. It's part three, deep sea. Let's go. So I give the question to DeepSeek. I need to give it to ChatGPT, which I'm gonna do right now. Take it. Take this. Copy. Paste. Okay. Overlay small. Let's go. We got the small speed. We got the small OBS. Okay. We got it. We got things under control. Pop the chat. Oh, whoa. Where's my channel? Okay. Now pop the chat. Arrange the windows. Oh, yeah. We live. We live. Fucking yeah. Okay. Oh, this. I'm sorry, that should not be here. That is for another different purpose. Okay, so ChatGPT gave me an answer. What's the final answer? It's W half. What do you got? What? Okay. So we square. Okay. Okay, almost. No, it's the same answers. So DeepSeek is correct. ChatGPT, you may rest. Because if I use you too much, I'm talking too much. Okay. Total capacitance. A capacitor supplied with constant voltage V by an external voltage source is dipped partially into a liquid bath with permittivity epsilon. The liquid inside the capacitor shows a higher level than outside of the capacitor. The capacitor stays connected to the voltage source when dipped into the liquid. What is total capacity? Energy stored of the arrangement with partially filled capacitors. Give an expression for height of the liquid. Calculate first the force of the liquid exerted by the capacitor. How does this force relate to the gravitational force on the liquid? I don't know. Fuck, I don't know. Total capacitance and stored energy. The capacitor is kept partially submerged in liquid dielectric permittivity to a height z, treated as two parallel capacitors. Air region. Epsilon 0 W h minus z by d. Liquid region. Okay, what are these values? What are these W's? H minus Z. Okay, that's the height, that's the length. Z, okay. No, capacitor that's above at the air. The liquid region total capacitance, it's going to be series connection, right? Maybe. Could be. Yeah, it's series. So oh, that's the first part. That's it. Second part, liquid rise due to electric field. Oh no. The force arises from the energy gradient as the liquid rises. Interpretation: the system minimizes energy by pulling the dielectric liquid upward, balancing chemical gravitational force. Capacitance increases linearly with submerged height z. Energy depends on the permittivity difference. System minimizes energy by pulling the dielectric liquid upwards. Force arises from the energy gradient as the liquid arises. Interpretation: the system minimizes energy by pulling the dielectric liquid upwards. Balancing gravitational force. A liquid rises until electric force balances gravity. Equate forces V squared W to the epsilon minus 0 PGWD delta Z. Solve for balance. Okay, the liquid rises until electric force balances gravity. Okay, so equate the forces. V squared W. So that is the total energy stored in the capacitor. Does that have any involvement? No, it does not have any involvement. 2D. Whoa. Which formula is this? Okay, took the whole thing. No, that's different. So that's the formula for electric force, and this is the formula for gravity. Damn, the part B looks really small, but that was not small. Man, a lot of. Where? How did you come up with this equation? P G W D delta Z. Delta Z, I got it. What's P? G, I guess gravity. W is voltage. What's D? D is the width. Okay. Liquid rises to a height Z. The capacitor remains connected to the voltage source, so V is constant. The origin of electric force. What? When liquid dielectric rises, it increases the capacitance of the system, which in turn changes its energy stored. The electric force arises from the system gradient, derivative of energy with respect to height electric force. Capacitance as a function of Z. Total capacitance is the sum of air and liquid currents. Simplify, okay, stored energy W equals energy stored in the capacitor. That's in volt, or it's calculated by capacitance. It's watts, right? Yeah, watts. So capacitance into voltage is the energy stored, half CV square. Half CV square. I heard that variable uh, order before. Half AB square, half GT square. Yeah, GT square. Okay, maybe. Nah, that's for another discussion. Substitute C, WZ equals. Uh-huh. And that is the energy stored. Force is a derivative of energy with respect to Z. Z interpretation, this force pulls a liquid upwards. The dielectric increases capacitance, lowering the system's energy, which leads the system or the plates to pull water. Balancing forces to find delta Z. The liquid rises until the electric force is balanced by gravity. We have to. How does the force relate to gravitational force? Balancing forces to find delta Z. The liquid rises until the electric force is balanced by gravity. Gravitational force. So, what is equal to solve for x? Solve for z, delta Z. Inverse dependence on P and D square. Heavy liquids rho or wide gaps D resist rising. I don't know what. Mhm, mhm. Clarifying variables in liquid equations. So it's voltage, permittivity, density of the liquid, oh, gravitational constant, acceleration, yeah, separation due to the capacitor plates. The other thing I need to know is what are these two equations? TION. I should close the window. I forgot. No more fucking insects of this. Mm-hmm. Energy as a function. Electric force is Derivative. It's a derivative. Derivative. It's a derivative. Derivative. I don't know, man. I forgot. I forgot. It's a derivative of W with respect to Z. The force is constant, independent of the Z, because W is linear in Z. It depends on permittivity difference and the voltage squared. Okay. Gravitational force, mass of the liquid rises to a temperature Z, delta Z, creating a column of liquid between the plates with volume volume W d delta Z. Okay. And mass of rho into volume equals, okay, that's how you okay. That's what I need to know. But this equation, what, it does not look similar to this. Substitute the expression. What do you mean? HZ. Hmm. How did you go from here? How okay, derivative. I did not understand derivatives. That's it. Original energy equation. Find the electric force. If electric is derivative of W of Z with respect to Z. Hmm. Let's differentiate W of Z by term by term. Okay. Lot of things goes out. H is a constant, does not depend on Z, so its derivative is 0. So we have, okay, and okay, Z was gone. That's how you took the derivative. I see you, man, I see you, man. And find the electric force. Let's differentiate by term. I differentiate, I don't know. And substitute the both values. So first you said, or GPT said, let's differentiate. No, first it said what? So derivative of energy. It's the energy equation. It's the energy release, or no, it's the energy. It's the energy. We would say this delta Z is traveled. It's the equilibrium where before the energy from the capacitor and the gravitational force having an equilibrium stage where the water stays still, I guess. So okay, so derivative of that. gives the equation that we need, and that's the derivative of W. That's an energy equation. So derivative of W is force. So derivative of energy is force. Okay. Yeah, I guess I can answer the question, right? And send it to send. I'll write it in a form I can understand. No. This. Peaches. So, third question. A total capacitance and energy stored. So total capacitance is C at air and C at underwater. The air one is epsilon 0 W H minus Z by D, where H might need to draw the structure. Okay, the capacitors. Let's get water, its watery color. Yo. We give water its color. Could you do that? We can do that. And the distance the water rose is Z. The total distance is H. Height of the capacitor. The width is D. Yeah. That is Z. So H minus Z is the one up the air, and the one underwater is epsilon W, right? Or you just wrote Z, okay, epsilon Z. Epsilon Z, W, Z, by D. And C total equals C air plus water gives W by D epsilon 0 epsilon Z into H minus Z into Z. Okay, now it's not into, now multiply, it's addition. Now I'm not writing that. Well, that's that. Now, uh, that's total capacitance. Now, and now we have to find the energy stored. It's W half C total V square. Also, I forgot what this W was. That's the width. W into H minus Z. Okay. So width into height. That's width into height. Is that epsilon 0 H minus Z plus epsilon 0 epsilon ZZ. That's what it is. It's the equation for energy stored. Let's go. Now part B. That's the one. It's a pretty hard one. Electric force on liquid equals gravitational force. And the equations are electric force is a derivative of energy, energy with respect, no, with energy, I forgot the term. So when liquid dielectric rises, it increases the capacitance of system, which changes the stored energy. So it increases the energy stored, right? Yeah. So the amount of energy stored will be equaling to, okay, so the insight with respect to the volume of the water. Yeah, so electric force is a derivative of energy. How do I explain it? Okay. Electric force. Okay, so I need to write a. So the capacitor has a tendency to. Water is a dielectric material which increases the capacitance if it's introduced to the capacitor. So the capacitor tries to increase the amount of water inside them until the capacitor tries no the capacitor having water as a dielectric medium. The capacitor having water as a dielectric medium. I'm zoning out. I don't know why. Maybe it's smoke, I guess. which, yeah, water as a dielectric medium, uh, which increases the capacitance, which ultimately increases the energy stored. S- So, so the water, so the water, okay, so it's not capillary action. Yeah, I mean, it's, yeah. What do you name it? Which ultimately increases the energy stored. So the capacitor will be able to store some store oh, how do you say it more easily? The capacitors having water as a derivative, the dielectric medium, which increases the capacitance. The water as a dielectric medium, which increases the capacitance and internal energy stored, um, which the capacitor will in which the capacitor will try to store until it, it equals to the force to pull water about compared to gravity. Okay, okay, okay. It equals to the force of moving water against gravity. So the how do I say this? Is it an equilibrium? The capacitor, the internal energy stored in the capacitor, it will be able to pull water until it equals to the limit where the capacitor cannot store more energy, or or it cannot move against, it cannot move water against gravity. It don't have enough internal energy to move water between its plates, which increases the capacitance and internal energy stored. It increases the capacitance and internal energy stored. Hmm, which leads the capacitor, the leads. So water is climbing on which? So the electric field lines, is that actually what pulls the water upwards? Yes, electric field. Until the point where the electric field force is equal to gravitational is equal to gravitational force experienced by the liquid between the capacitor, which leads to in which the electric field lines pull in more water in which the electric field produced would pull in more water between the plates. And the equation for that, so this person converted energy to force, right? Not this person, ChatGPT. So total energy stored in which? Mm, So so the energy for W is passive to electric which equals to gravitational force experienced. I mean, it's electric field. Energy stored in capacitor connected to constant voltage source. Electric field on a dielectric is dW. Okay. This derivative guide the force exerted by the electric field to pull the dielectric water up. Gravitational force on the resistant liquid. The the elect, electric field force F E equals dW by dz. Derivative of stored energy. Which from there we can. So at the end, the equation is going to be WV squared by 2D epsilon 0 plus EZ, right? Epsilon minus epsilon 0. Okay, so it's epsilon z minus epsilon 0. So that's the derivative. And this electric force equals the gravitational force experienced by the volume of water arised. So that will be Fg equals volume into volume into what? Forgot. Volume into density? No. Gravitational force, uh, mass into volume. Where's G? The electric force equals at equilibrium, yeah. Mm, mass, okay, so force is equal to mass into gravity acceleration. Density, which will be giving us the final equation, rho w d. So wv square by 2d equals delta rho w d delta g, and wwd, okay, ww delta z g. Delta z equals now I don't want to calculate that with values. Rho is density of water, right? Density of liquid, gravitational force, width, V voltage, Ez minus epsilon zero is the difference in permittivity. bigger permittivity difference, more polarization, more force. Yeah, I think I got it. Yeah, that's the equation. Well, I did finish the physics assignment. We did it. Is the name Josh Aber? K 1 2 3 4 8 0 0 8 0. Gotta print this. Gotta print. I have to. One more thing. The force. Okay. Now we're sending it to print. Yeah. Save the files. We're saving it to master man mass physics. We saved it. I just gotta upload it to the website. Fast. Come on. If bro, my computer is so fucking slow that sometimes you just wanna type in. Add submission. Okay, submitted it. Now I just gotta checklist. I did every question out there. One eight way, yeah. This was actually much easier physics assignment. It was pretty good. Uh, the physics assignment is over. Now it's time for chemistry, chemical calculation. Let's go. Chemical calculation. Oh shit! I gotta download it. Mm, let me know. Okay, exercise sheet 7 for chemical calculation. Where can I download this? Come on. My courses is my course. Okay. I think we're done with 7 and they uploaded 8. 6, that just went past 7. Oh, they uploaded both 7 and 8. New folder, assignment. Assignment 7 and 8. So I got okay 8. Physics is submitted. Oh, thermodynamics. I cannot forget those. Where's my man? Full charge. Okay. It's full. It's got full. Eh, Tumbeva, tunjatarata, tunjate, unyarila, tumbeva. Chemical thermodynamics, when should I submit exercise 2? It should be submitted in 15 days. Nah, not that big. Not that big, not that big, not that big. Thermodynamics. Actually, yeah, make it exercise 1, 2. Take all. That's it. 1, 2, 3, 4. In which I have submitted 1. Let's submit 2. So I have an exam, math exam. I forgot the topics, everything. It was mathematics for biological chemistry. I got them PDFs. Maths Biochem 1. What? These are questions. Okay. Okay. Now, derivatives, mathematics, application. These PDFs have a lot. I don't. I'm not gonna do all these, bro. I actually read the first PDF, if I remember, and I forgot the whole graph and polynomial functions. It's a mess, bro. I mean, I think the questions are also similar, right? Derivatives, math for chemist, winter semester 4. Oh, that's not it. What are so? Whoa. The exam questions span several topics, both in mathematical analysis and biophysical application. Calculus, function analysis, biophysical modeling, continuity, and differentiability. Mhm. Function identification and convexity. Yeah, I think these are main topics to study for the math exam. Then I got physicist exam was with the physicist physics for biological chemistry. But I got questions. If I could answer all these questions, I think I can get it right. Even I got answer solutions. Yeah, physics. I just have to do all the questions. That's it, and I will do it today. Yo, maybe every. I have to keep switching subjects in every 30 minutes. Yeah, so that's the new plan. Gotta do um, every every 30 minutes. I have to keep changing the subjects. Oh, bro, Siri, I. But you know what I can do right now? I'm gonna watch. What? Siri, what do what do you know? No, what did you said that you know? What do you know about me? What do you know about me? Okay, that was so weird. And I have to do the assignment, right? Oh shit. Oh, don't show you. Assignment number 7. Ah, man, 4 pages. Come on, we got news, man. We got news. We got news. What I do to you? What I do to you? What I do to you? I've done nothing to you. This guy goes to my back. My back. My back. Blam, blam. They see me rolling. I'm gonna upload the whole thing to DeepSeek. Where's my Oh, okay, I closed PyCharm. Now it's only the video. Late Chandler's principal prediction. Wow. I need to take some time rest. Tomorrow I'll be streaming morning. I'll be for sure, man. Gotta wake up in the morning. Peace out.